Hello, welcome back to another video. Today we're looking at strings in Rust, which is a little bit of a special thing to deal with when you're coming from other languages, like I do. So this is probably going to be a very interesting episode of this video series. Speaking of which, I'm actually publishing 2 to 3 videos every week. So if you like this video or any of the other ones that you might have seen already, maybe you want to subscribe to my channel. Okay, with that out of the way, let's take a look at our exercises today. Okay, so I've already executed rustlings watch inside of the rustlings repository, and here we can see that there is a compilation error in exercises strings and then strings1.rs. Now the compiler is complaining that in the function current favorite color, which expects a string as a return value, but apparently it's not really returning a string here. There's a string blue, and then the compiler says it expects a struct string, but it found a reference stir, also known as a string slice. We've already talked about string slices a little bit in one of the previous videos of this series, so make sure to have a look at that. Okay, and then the compiler also gives us help and says, hey, look, try using one of the conversion methods, something like blue.toString, for example. So this is another very good example of the Rust compiler helping us by giving us a very good hint about what's going on and what we should be probably doing to make the code compile. Even if it doesn't make a lot of sense right now, why this is happening, we get to that in a second, but I think it's good to appreciate that for a moment. Okay, so let's have a look at that file. So I'm gonna open up strings and then strings1.rs. Okay, and then here we can see that we have a function main with variable answer that we get from current favorite color, and then that color is printed to standard out using printline. And current favorite color, yep, here it is. Here it says it returns something of type string, and then it returns this blue string here. Now, as the compiler already said, the function should return something of type string as defined in the method signature. However, right now what it returns is a string slice. And a string slice is really just a reference to a string. Now, you might be wondering, how can that be a reference when this string is actually not coming from anywhere? Like, we haven't really created it somewhere and then we're referencing to it, or we also haven't read any file contents that we're referring to. There's just this one little string here inside of our code, and it's apparently a string slice. I'm gonna explain in a second why that is. Let's first see that when we turn this string slice into an actual string, and we can do that using the method that the compiler proposed, which is toString, we'll see that this is going to compile, yep, and the compiler is happy. Another way to do this would be to call string and then from on it, which is a static method on the string type to create string structs from string slices, for example. So let me save that, and we see this is also compiling. Okay, cool, but still, it doesn't really make sense. So what's going on there? Actually, turns out I've written an article about this, and there's a bunch of visualizations there. So let me just open that one up to help you explain what's going on. So I'm gonna go to thoughtram.io, and then we have a block here, and then if we scroll down, there's string versus, let me actually zoom in a little, string versus stir or string slice in Rust. So gonna go into that one. This article explains exactly why the things are behaving this way in Rust. Here we see, for example, I'm gonna zoom in a little bit more so it's easier to read. Okay, so here we see we have a function main where we create a variable with a string, and then we call greet on it, and greet really just outputs it. And here we see that greet takes something of type string. Okay, wonderful. So now when we execute that code, we'll see that the compiler complains that it expects a struct string, but it founds a reference stir or a string slice. And also here, the same kind of hint that we got from our error as well is to call toString on it. We need to understand how data is stored in Rust, and how data is stored really depends on what data you're dealing with. In case of a string, it looks something like this. So first of all, there is a stack frame and there's a heap. So these are two different places where we can store data, or where Rust stores data, or where programs store data. And depending on what data you're dealing with, your data either goes on the stack or it goes on the heap. There's some benefits and some trade-offs depending on where data goes. One is faster than the other. Okay, so when we create something that is really indeed a string type, it actually gets stored on the stack frame, but not the whole string, but only the string struct, which is a data structure that has a pointer to a buffer that holds the actual data. That data, which for example here is the string Pascal, which is my name, that data ends up on the heap. Then it also stores the capacity, which is the available space to that particular struct. And then it also stores the length, which is the actual length of the buffer. So by having a string, we can determine, okay, the string has this capacity, it has this length, and it also has a pointer to the actual data. Okay, cool. So that's a type string. Now, what you can do with the string is actually you can change the size of it. You can append another string to it. And that's also one of the reasons why the data actually ends up on the heap, because it can grow in size, while data on the stack is usually static in size. Okay, so now what's the deal with string slices? A string slice is really just a reference that points to parts of that string that you're dealing with. So for example, here we see we have a string Pascal, as we've seen earlier. We append another string here. And then what we do is we create another variable using this slice syntax here. And we say, okay, create a string slice, which is a reference to my name, but only anything starting at this point in the buffer until the end of the buffer. Okay, so if we visualize this, it looks something like this. We have our variable my name, which is still the same thing. In this particular case, it's a bit bigger because we have the first name and the last name in it. And we see it has the capacity and the length. And then we create another variable, last name, which is a string slice. And string slice is also, as you can see, really just a pointer. It's a bit smaller. It doesn't store the capacity of the string. All it needs to know is the pointer where it starts and the length, right? So in this particular case, here we have the pointer, which points to this slot here of that actual string, and then it has the length, so it knows this particular part here is the string slice. So it's really, if you will, a window into an existing string. And that's also why it's a reference and why you cannot own it, because it's owned by my name. So that's the difference between a string and a string slice. Very important thing to understand. Okay, with that out of the way, we now at least know that we can solve this particular issue here by either returning string from blue or by calling blue.toString on it. Now, which one you want to use depends a little bit on your use case. It doesn't make a difference if you use string from or string slice to string, but for now we're just going with toString. Okay, I'm gonna save that and remove the comment here and head off to the next one. Okay, so now in strings 2, there's a function that is a color word, and it takes something which expects it to be of type string slice, but it found a struct string. Okay, so let's take a look at that file. Okay, cool. So here we have a function we call string from green, and we should not try to change this line. Okay, fine. So we have a word which is of type string, and then we have this function is a color word which takes a word, and then we print something out here. Otherwise, we print something else out. Wonderful. Okay, cool. And then we have this function is a color word which takes indeed a string slice and returns Boolean. And here we see it's just comparing the given value with other string slices. Now, the compiler is complaining that we're calling this function with something of type string. So now we know the difference between a string and a string slice. These are two different types. Now, how do we make this work? So it turns out that this is actually solved very easily by simply passing a reference to our string to that function. So if I make this a ampersand word, if I borrow the value to the function, we see that this is compiling. Now, why is that the case? Okay, so there's this cool thing in Rust where the compiler is able to take a value of a certain type and turn it into its reference counterpart if there exists such a thing. This is called deref coercion. I'm not sure if I pronounce it properly. It's kind of a hard word. But when it comes to strings, basically what this means is if you have a function like isAColorWord, which takes a reference to a stir or a string slice, a reference to a string slice, then whenever you give it a reference to a string, Rust is automatically turning it to a string slice, because it's really just a pointer at that string with a starting point and probably an end point. Now at this point, you might be wondering, okay, why would you want to create a function or any API that expects either a string or a reference to a string or a string slice? Obviously, that really depends on your case. Most of the time, if you don't want to change the data that you're dealing with, you're probably just interested in references to it, so you don't have to pass ownership around. When it comes to strings, most of the time you probably want the string slice type, because any borrowed string type can be turned into that. And then the cool thing is there's a bunch of cool APIs on a string slice type that you can take advantage of, even though when the caller of your function has only a string available. Okay, that's it for this video about strings in Rust. Hopefully that gave you a little bit of an idea what a string is, how it's stored, what a string reference is, what a string slice is. I know it's a bit confusing. It was actually one of the first roadblocks that I ran into when I learned Rust. Yeah, hopefully that helps you a little bit. And yeah, make sure to check out the other videos and see you around.